Yep, so I'm Manny, and I'm with the Line Technology Group, and we're an advanced AWS partner, and we focus on leveraging automation to help folks adopt and sustain cloud adoption, specifically within AWS. You can find me on LinkedIn, usually speaking about AWS security, cost optimization as well. So today we're going to cover a lot of ground in this session. I want to thank you ahead of time for your engagement. We're going to talk about the Security Reference Architecture. The SRA essentially lays the foundation for how organizations ought to think about securing and monitoring their AWS workloads, right? And a workload is an application, a system, what have you. The important takeaway from here, even if I happen to lose you in some of the AWS jargon, is that you really need to focus on a multi-account strategy. It doesn't matter if you're using AWS, Azure, or GCP, right? The same concepts apply. Segregating those workloads between a project or account, what have you, being able to apply granular, categorical security safeguards, being able to control what people can do within an account, being able to foster innovation within the cloud environment without putting the organization at risk is incredibly important too. And then being able to accurately cost what a project, the workload is costing the organization, whether because you have to do chargebacks or showbacks, or basically you just want to know how much it costs, right? So if you could, and if you don't object, because you know who I am, right? So I'm not going to hack you with this QR code. There are two documents that I'm sending you to. One is the Security Hub integrations document that basically shows all of the AWS services and the third-party solutions that integrate with AWS Security Hub. And we'll talk about Security Hub later. Security Hub can ingest data, it can send data, but it is really the way that, the glue, if you will, the proxy to get things going within AWS. And then the second document, because we'll be covering a lot of AWS services, is essentially a reference sheet. You can figure out what I'm talking about when I say AWS config or, shield. You can reference that document to quickly understand what that service is, and that way you can follow along more easily. And I'll leave that up there for about 10 more seconds. All right. Okay, so the AWS Security Reference Architecture, or I'll call it SRA, aligns to the cloud adoption framework that AWS has published. It aligns to the AWS well-architected framework, the AWS shared responsibility as well. And the cloud adoption and well-architected frameworks are really best practices. And you'll see that when we start to cover both in a minute. They're best practices that essentially propose a set of security perspectives, design principles, and the shared responsibility model really helps the organization understand where their responsibilities begin and end, and where AWS's responsibilities begin and end. I want to caveat, though, that it really depends on the workload. If you have a serverless workload, it's a much different conversation than if you're using virtual machines in EC2. So here's the AWS Cloud Adoption Framework, the security perspectives. Most of these should be, or all of these should be very familiar to you. These are essentially aspects of security that any security program really needs to, maintain some degree of security within an organization, right? Everything from security governance to incident response. The one that I'll emphasize today more than any of the others is identity and access management. It's key to helping protect your workloads. And AWS does offer some very creative ways to provision access without having to provision interactive console access, right? So in AWS, you can have programmatic access using keys, access keys, or you can have interactive access using a user ID and password, preferably with MFA, right? Especially if you have the root account. But also you have things like cross-account access, right? Where you can create a role in the target account that has the things that you want to see and administer. And then you can create a policy in the source account, the account that you're in, right? That basically gives you the right to assume role. And then you can assume a role from one account in another account with very specific permissions. I call them constrained permissions, right? Or sometimes admin permissions too. So the AWS well-architected framework, it promulgates a lot of different principles. Here are the security design principles. And the security design principles are essentially guidelines that AWS, and for that matter the industry, thinks are necessary to protect any workload in any environment, specifically cloud, right? And so you're focusing on things like identity and access management, logging, monitoring, detection and response, automation using infrastructure as code, right? Terraform or CloudFormation. And then protection of data in transit and at rest, usually with HTTPS. By the way, and I mentioned earlier, with respect to access management, you could provision access creatively using cross-account access, as opposed to giving someone interactive console access. And that's really preferable, right? Because in a lot of cases, you're having to give folks very granular access. Let's say a developer wants access to a production environment. Well, your auditors may not like that, right? So you have to be able to justify the access and control that access such that when that developer has access to production, they can't see data, right? They can't make any material or significant changes to production. They may need it just to view logs, right? They may need it to view settings. So read-only would be the best approach, right? You can do that now. You can do that now without giving them access to the entire workload within that account. When I say account, I'm talking about an AWS account that contains a workload. It contains all the requisite AWS services and infrastructure that make up your application, your system, whether it be a front-end system or a back-end system, not necessarily a user account. When I talk about user accounts, I'm talking about principles, right? A user, a group, a role. And we'll talk a little bit more about identity and access management here in a minute. So the AWS shared responsibility model, it's not a one-size-fits-all, right? Your workload is going to dictate what the shared responsibility model is, right? Generally speaking, though, you're going to be responsible for securing the data, right? The code. In certain cases, if you have virtual machines, you're responsible for patching, right? Security group firewalls, you are responsible for controlling inbound and outbound control, right? NACLs as well for an VPC. While AWS is really responsible for the underlying infrastructure, right? In a lot of cases, it's going to be that hypervisor, making sure it's patched, up to date, secure, any underlying network infrastructure as well, right? The underlying infrastructure associated with an AWS service is AWS's responsibility. The one area where I said it really does differ is where you're adopting serverless. Serverless is a concept where you aren't necessarily responsible for the underlying infrastructure. In fact, you don't have much visibility over it at all. You provision code on an AWS service, and it works, right? Or at least you hope it works, right? S3 is technically serverless. S3 is where you store data, right? In blobs or files, right? It's not really block store. block storage. But it's serverless. You're not really maintaining the underlying infrastructure that stores your data. You're actually just responsible for securing the S3 bucket and the data that it contains. So this concept, multi-account strategy, is incredibly important. And the reason it's important is because, by the way, does anybody notice that this terminology is very similar to like Active Directory? Anybody familiar with Active Directory? Yeah. So there's an organizational unit, just like in Active Directory. And an organizational unit is going to contain your accounts. The AWS organization that has a root account, a management account, right? All the magic happens from the management account. You should really limit who has access to the management account. It's like having domain admin privileges, right? So each org contains accounts, and those accounts should be similar in nature, not necessarily separated by function, or rather by business unit, but by function. If you have workloads that all have to comply with HIPAA, probably be a good idea to put them all in a HIPAA OU, right? PCI, similarly. Let's put them all in a PCI OU. Doesn't necessarily mean they're in the same account. You can have different components in different accounts, right? Different workloads in different accounts. But ultimately what you want to do is segregate such that it makes it easier for you to control access, right? You can give a developer access to a non-prod environment without risking that the developer will gain access to production data or systems, right? Similarly, your accounting and finance team may come to you and say, hey, how much is it costing us to run this project or do this for a specific client? You know, maybe you're a multi-tenant product and you run a separate instance of the product in an account for a client. Well, how much is that client's infrastructure costing you? Are you profitable, right? So separating things into separate accounts helps you determine that through billing. And again, if you have specific security and compliance requirements, you can apply those safeguards granularly, right? At the OU level preferably, not necessarily at the account level, so that you don't have to apply the same safeguards across different workloads. Let's say you have folks in the EU. You've got to keep data there for GDPR reasons. Well, if you have an AWS organization, you can, in fact, prevent anybody in the EU from using any regions that are in the US or anywhere else for that matter, right? And you can apply that policy to that organizational unit and that organizational unit only. Everyone else gets treated a little bit differently. Well, you might have some clients who don't want you to store data outside of the US either. You can do that. You can provision their environment such that the administrators, the developers, cannot deploy or access or administer data outside of the US. Okay, so you have the concept of an IAM principal, which is essentially a user, group, or role. It's important to understand that a principal does not have any permissions, privileges, right, out of the box. You're going to have to give them permissions, usually by putting them in a group or assigning them to a role, right? Service control policies are essentially policies written in JSON format that prevent an account or anybody in that account from doing something that is already allowed, right? So let's say they're allowed to actually leverage or provision any EC2 instance they want. You can actually deploy a service control policy that limits what sort of EC2 instance they can provision. So on the top left there is a JSON policy that basically says, and this is the policy that gets provisioned right out of the box, right? You provision an account, and anybody in that account, provided they have the permissions, the admin privileges, they can do anything in that account. Use any region, deploy any resource, what have you. Service control policies actually help you dial that back a little bit. So now we'll discuss the organizational units that are pretty typical, or at least they're things to think about, right? They're kinds of services that you should group together in an AWS organization to essentially help you achieve, some degree of security and secure compliance. So the management account. This is what gets deployed, and essentially it's like having domain admin privileges within AD, right? Just the context is an AWS organization. An AWS organization starts with a few accounts that we'll describe over the next few slides. But the org management account is where you administer the org. This is where you apply service control policies, right? One caveat though, any workload that you provision in the org management account doesn't have to comply with any of the service control policies that you deploy, right? So that's why it's a really bad idea to deploy production and non-production workloads in the org management account, because if you do, nothing that you introduce, service control policies, which we technically call guardrails, those don't apply to any workload in that management account. You should also limit the amount of folks who have access to the management account, because again, it's like having domain admin privileges, unless of course you're doing some things within the management account to reduce those privileges, right? Constrain those privileges. The org management account hosts what they call the root of the AWS organization. This is again where you configure service control policies. Remember that service control policies don't really grant permissions, they actually remove permissions, right? There's this policy again that gets deployed when you deploy an AWS account called AWS full access. That's what gives anybody, or at least the root account that initiates the org, access to anything in the environment. AWS CloudTrail is a service that facilitates logging and monitoring. Essentially, it logs any interactive console access, any programmatic actions against the API, command line interface. It's an absolute must, right, in an AWS organization. And you start with this thing called a CloudTrail organization trail, and then you can actually delegate, right, such that you can create a trail on a per account basis. Okay, did I go backwards? Okay, no. So then you have the security OU, which contains the security tooling account. And the security tooling account basically serves as the admin account for centralized security services. You could, in fact, separate these into multiple security accounts, right, depending on how you're organized functionally. And it's really designed to enforce those guardrails we talked about, and this is where your security analysts operate, right? You have all of the AWS services and potentially even some of the third-party tools that you've deployed. I've seen it do both ways, where people just have one security tooling account, everything's in that security tooling account, or they separate things such that, if I have a dedicated team that's responsible for key management, right, and encryption, then maybe the only thing I deploy into that security tooling account or the encryption account is KMS, right, or secrets manager or parameter store, if they're also responsible for privileged access management. If I have a third-party solution, I could deploy that into a separate account, or I can deploy that within an account. It all depends the extent to which you actually have to granularly control access, remember? If you have certain aspects of the team that shouldn't have access to other services that they don't administer, then probably a good idea to separate those. So we talked about Security Hub. That ingests data from various sources and enables you to assess, enrich, prioritize security alerts. It's like a SIEM, but not really, right? It's where you can send your guard duty findings. It's where you can send config findings, right, and aggregate those. but it doesn't necessarily replace a security information event management solution, right? Somewhere where you can aggregate logs, somewhere where you can do a little bit more correlation, right? Generate alerts that are very specific, but certainly capable if you don't have a security information event management solution to which you can send data, like a Splunk or a, Logarithm or what have you. The other service that I'll highlight here before we move on is just Amazon Inspector. So it's a vulnerability management service. So it does vulnerability scans. You can put an agent on an EC2 instance and get some more information than you would through other scans. And then, of course, you can do vulnerability management using Inspector, or you can identify those within Security Hub. So the log archive account ingests and archives all the security-related logs and backs it up into one S3 bucket. That data is immutable, can't be changed. It's durable because it's in a bucket. It's not going to lose log data as a result. It has high integrity because you can't make any changes, of course. And then, of course, given that S3 buckets are deployed with no public access, you have some degree of confidentiality. Durability is a measure where that measures really the likelihood of loss, right? So the likelihood of loss, data loss in S3 buckets low, right? Availability is the likelihood that the data is going to remain available, right? And because a characteristic of S3 is that it stores data in a multi-region capacity, so not just one region, but multiple regions, your availability is high too. So logs are encrypted using a server-side encryption with KMS, Key Management System, or service rather, and that ensures your confidentiality of logs as well if you have a regulatory requirement to do that. And then CloudTrail provides that log file integrity validation to ensure the integrity of the logs as they're sent and stored in that S3 bucket. Let's see. What that means is that no one can make changes to the logs, right? No one can view the logs unless they have permissions, right? Unless they have the appropriate role to do that. But it means that, yes, the technical controls that Amazon has implemented on the back end help enforce a high degree of durability, high degree of availability, and immutability, right? Make sense? So here you have the infrastructure OU. It contains the network account and the shared services account. By the way, you could come up with your own reference architecture. This is just a guideline, a suggested approach, if you will. But the network account is one that's very interesting, and I'll explain that next. So this basically acts as a gateway. A lot of organizations will expose to the internet their workloads, their front-end workloads, not realizing that they could use a network account to basically control all inbound and filter all inbound and outbound traffic, right? And you can see there in the top left corner you have the inbound VPC, the virtual private cloud. It has an internet gateway. It might include a network address translation. It produces flow logs. Then you have that outbound VPC. That's where you put your proxies, right, your forward proxies. And by the way, that inbound VPC can have a reverse proxy, a load balancer, whether it's an application load balancer or a network load balancer. Then you have that inspection VPC where all traffic is sent to for inspection. That's where you do your intrusion detection, intrusion prevention. That's where you have your firewalls, right, whether they're third-party firewalls or whether they're AWS network firewalls. This is where you might enable Shield Advanced. Shield is a distributed denial of service service. Hate to be redundant there, but essentially Shield Standard will cover you for most network layer DDoS attacks. And then with Shield Advanced, you're going to get a little bit more capability to cover layer 7 application-related attacks. And there's cost associated with using some of these services, though, right? So guard duty is not cheap. Shield Advanced is certainly not cheap. It's $36,000 a year, $3,000 a month. It does come with WAF, right? But WAF, alternatively, if you're using Shield Standard, does come at a cost as well. So every ACL is $5. Every rule is $1. And it doesn't matter if you have attached it to a resource or not, like a CloudFront distribution or an application load balancer. You're still going to pay for it. Any questions on anything here before I move on? Okay. All right. Let's see here. Got something in my way here. Okay. The shared services account supports the services that applications and teams rely on, such as directory services, metadata services, messaging services. You have this service called AWS IAM Identity Center. It used to be called AWS Single Sign-On. It's essentially a federation service, just like an Okta, where you could federate access to the accounts themselves, right, through cross-account roles. You could federate access to third-party software as a service solutions. So essentially, it's Okta, but AWS branded, right? Your directory services are just that. Your LDAP directories. You could have AWS managed Microsoft Active Directory, if you please. All the accounts on the bottom, Security Hub, Guard Duty, Macy, Config, Analyzer, those are all in the security tooling account, except for the organization trail. The organization trail, that just means that within that AWS organization, the administrators have actually deployed a CloudTrail organization trail for that account, right? And you do want to collect CloudTrail logs for each account. Otherwise, you're just not going to see any of the activity, VPC flow logs, any of the activities or actions against your API, any of the activities against interactive authentication, for example. You're not going to see any of that. Okay, so here you have a workload OU, and a workload OU contains one workload per account, right? And then obviously an organizational unit can have more than one account. There is a limit, though, just like Active Directory. I think Active Directory, it's best not to go beyond 3 nested OUs. I think in AWS, I think now it's 5, right? So you want to avoid nesting too many OUs. I'm not sure that I have seen that, nesting beyond 1 or 2 OUs. It's just not very common. It might be something you come across, though. And again, so the workload is contained within an account. When you provision an account, by the way, it doesn't have access to any other account unless you actually provision that access, right? And sometimes you can do that accidentally. I'll show you in a second. So here's just some random workload, right? I see those things in the middle, those endpoints, right? Those endpoints actually allow communication with other services and other accounts on a case-by-case basis, right? You have to configure it. So if, for example, you see that your transfer costs are high or spiked, check these VPC endpoints or check into using these VPC endpoints, because essentially what's happening is your VPC is communicating with the service and it's transferring data, and those transfers are occurring over the internet, right? So for example, if you're storing data and retrieving data from S3, you're actually doing that over the internet, right? So when you retrieve a file, you're doing that over the internet. There's a cost to doing that. It's called a transfer cost, right? So using these VPC endpoints, you can actually keep that transfer data on the internet, or on AWS rather, so that you don't experience those transfer costs. You can ensure a higher degree of security, right? You can apply some privilege constrained policies as well, right, to control access. Unless, of course, you provision the endpoint with a wildcard. And that just means that you gave anybody access, right? So avoid the wildcard when you provision an endpoint. So things to keep in mind, organize your AWS environment based on security, compliance, functional needs, avoid deeply nested OUs, assign a single account, or a single or small set of related workloads rather, to an account. Apply those guardrails, right? Don't forget about this security control policies, or service control policies rather. And also config policies. Config is detective, service control policies are preventive. So you do, if you want to prevent somebody from accessing a specific service within an account, you want to prevent your developers from deploying those really extra large EC2 instances, to mine Bitcoin, then you can do that from the management account and apply that service control policy from the management account to prevent them from doing that. The management account, again, avoid deploying workloads to the management account. That's a big no-no. You'll find that in organizations that actually grew over time from one account to multiple accounts, and they still have workloads in that management account. Again, segregate production workloads from non-production workloads. Do that by placing a non-production workload in one account in a separate OU and putting production workloads in another account under a separate OU. Automation. Rely on automation, preferably infrastructure as code to deploy your resources and configure those resources. You could do that with CloudFormation. You could do that with Terraform. We're a Terraform shop. We can do a lot with, CloudFormation, but I think Terraform gives you a little bit more flexibility, and it does support that multi-cloud, approach, right? So if you're deploying resources to GCP as well, or even Azure, you can do that through Terraform. CloudFormation, you're going to have to live with it because a lot of times third-party integrations tools, they're CloudFormation scripts, right? They're not Terraform scripts. But do evaluate your infrastructure as code before you deploy it. So invest or subscribe to a infrastructure as code scanner that can actually identify issues, configuration issues, before you actually deploy that. And if you're being asked to deploy a infrastructure as code, whether it's Terraform or CloudFormation, then evaluate it, right? You want to look for things like access to all things, administrative access to all things, access to services that it shouldn't really have, right? If it says it's read-only, it should only have get and list, permissions, and so on. And then manage access. Use federated access to help simplify managing human access to accounts. Use those cross-account roles that I talked about, right? Essentially what that means is that I'm logging, let's say you have to give a third-party access, right, like me. I'm going to come in and do an architectural risk analysis of your AWS environment, whether it's one account or 100 accounts, doesn't matter. Instead of giving me access to the accounts, right, directly, what you want to do is give me cross-account role access. Then I log into my account using MFA. From there, I can actually log into your account with those constrained permissions. If it's read-only, it's read-only, right? If I can only deploy EC2 instances or restart an EC2 instance, right, a virtual machine, then that's all I get, right? But that's how you handle that. Any questions on any of these? Yes, sir. Yeah. Yeah. The answer is yes. I will caution you, though, do a lot of research before you commit to, for example, using Well, yes, the answer is yes. I'm not going to get into the details, but yes, you can use Terraform, CloudFormation to deploy your entire environment. Some things you want a little bit better control over, right? Deploying an AWS organization is easy, really easy. Like literally would take me, besides spinning up all the resources, the actual act of deploying it takes 5 minutes. Click, 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 yep, done. Wait 2 hours, grab some lunch, come back, and it's there. But yes, technically you do want to have better control over how you deploy any AWS services, any infrastructure within that AWS org. I think it's going to be a little bit more challenging if you try to, actually deploy the org in its entirety, because there's things that go on in the background that you may not have visibility over, and that you're probably not going to get right in a Terraform, in Terraform or CloudFormation, right? So there is a GitHub code repository. There's actually a couple now. One is for the SRA, the other one's for the landing zone accelerator. You can use those to deploy your environment. I can't say they're actually complete. There's a lot of configuration that you have to do, and they're in CloudFormation, right? So if you're a Terraform shop, this isn't really going to help you, unless of course you're evaluating what it's doing, right? And then you're duplicating that within Terraform. I didn't know that was happening, but I guess I turned that on like midstream, didn't I? Because it was in my way. And my only option was turn it on. So there you go. Let's see. Some useful references. It took me 2 or 3 reads to understand what was going on with the security reference architecture. I will not lie. It's not terribly complex, but there's a lot of moving parts, right? And it's always taken me a couple times to kind of let things sink in. So don't feel bad, Do give it a read. Do understand, the ecosystem of services, whether they're AWS Cloud Native services or third-party solutions and how they integrate. Again, Security Hub is a central focus, for a lot of it. Again, you send data to Security Hub from AWS services or third-party solutions, or some of those third-party solutions have the capability to ingest data from Security Hub as well. The AWS centralized logging document is really interesting, and it has a lab that you can go through. I caution you first to either have your company pay for the lab, because some of these labs can get pretty pricey, right? Again, just understand when you're dealing with AWS services that actually costs, and understand the cost driver, right? And understand that when you provision some services, even if you don't attach it to a resource like a web ACL, it still costs, right? It's generating costs. EBS volume, right? Basically block store that's attached to an EC2 instance. You stop that EC2 instance, you're still going to pay for the EBS volume. And you pay for the whole thing, not just what's stored inside of it, right? So if it's empty, you're paying for it. Terabyte, you're paying for it, right? What's going on here? Okay, so a little bit about us, Align Technology Group, based right here in Raleigh. Everybody's in Raleigh. Well, one guy's in Charlotte. And we focus on cloud advisory, FinOps, cost optimization, engineering, primarily through Terraform, deploying through Terraform, and then, of course, cloud security. All right. Thank you very much, and I appreciate your time.